All right, this is a very quick video about how to modify your LNR MTR3B, the older version, to swap the 30 meter band to 17 meters. So someone might want to do this with the solar activity, allowing for higher frequency use on the bands. 17 may be of more interest than 30. So if you want to do this and you have one of the older models of the MTR3B with the LED as opposed to the LCD, you should be able to do this. And it's a fairly simple process. There's a great little procedure written by K6ARK on the soda reflector. If you search for MTR3B band swap mod, you should find it there, and it lists all the components that you'll need in order to do this mod. So the first thing that you'll need to do is confirm that your version actually has the firmware installed to allow for this swap. So it's very simple. You're going to take the two screws off the side and pull off the bottom, and the way to test to see if the firmware is has the 17 meter mod capability, if I zoom in here. So you've got R2, which is right next to the antenna connection. My radio is a little different. I've got a SMA as opposed to the standard RCA jack that goes to a BNC connector, so yours may look a little different. There's also multiple revs of this board. This is a version 2 Rev A, so there's a couple little modifications in the board itself, but you'll need to essentially tack a 50 ohm resistor, or about 50 ohms, 51 is what I used, across R2, which is this one right here. And when you tack the resistor across there, and then when you switch to the band 2 position on the other side, let me zoom out here, we're in band 2, and once you have that resistor in place and powered on, you should see the 7 there for 17 meters. So originally it would be a 3 for 30 meters, and if you had it in the 40 or 20 meters, you'd either see a 4 or 2 on power up. When you have a 50 ohm there and the firmware is installed, you should see a 7. And so if that's the case, then you're able to do the modification, and you can proceed. So the first thing to do then is to swap out that SMD resistor R2 for actually a 50 ohm SMT resistor. So just using a soldering iron, applying heat to both sides, you can remove the existing resistor. I'm not sure what the actual resistance is for the 30 meter setup, but you'll swap that out and put a 50 ohm resistor in there in R2. And I didn't use any solder paste. I just used a soldering iron and very carefully removed and soldered in the 50 ohm resistor. The next step is to actually, and I'm not going to do this on video, you have to access the transmitter side of the circuit, which is on the opposite side of the board. So you'll just unscrew the these two jacks and take off the antenna connector, and then remove the 4 screws in the corners, and you'll be able to pop this board out and access the other side. And once you have access to the other side, the components that you're going to be working on, so the 30 meter filter torroids are the center ones, and you'll see on the other side there's a bunch of capacitors that need to be replaced on the other side that are basically right underneath this middle set of toroids. So what you're going to need to do is remove C49 and replace it with a 22 picofarad capacitor. Then remove C46 and C59, install a 100 picofarad capacitor for each of those, and then remove C54 and install a 220 picofarad capacitor. Those are actually the larger SMD components. You can use, I didn't have the larger ones, so I just used these the smaller ones, and with enough solder you can make the connection just fine. But you'll see that when you flip it over, they are larger SMD components, so if you can get the larger ones, they will work probably a little bit better, but you can make do with whatever you have. And then the next thing you're going to need to do is come back to this side of the board and replace L4 right here, also close to the antenna out. Replace L4 and L9 just below that, so these two right here, again right above the middle set of toroids here, L4 and L9, and you replace those with a 8.2 microhenry inductor, so same value. Replace those, and then once you're done with that, you're pretty much done with all the SMD work, and then you go onto the filters here, and what you're going to need to do is remove these two toroids, and once you have them out, all I did was remove, you have to remove 2 turns, I just removed 1 turn from each end and reinstalled the toroids with the 2 turns removed, and then just clip the excess on the other side, and you solder these from the other side, obviously through hole. So remove 2 turns from each. Again, I just did 1 from each end, and then reinstall, resolder, and then clip the excess on the other side. And then once you're there, you've pretty much done everything, but you do have to adjust there's a couple of little pots on the other side, and again I can't show you, but there you'll see 2 sets for each set of filters, and they're fairly obvious as to which ones go to which, because they're vertically aligned with each of the 3 sets of toroids on the other side. So the best way to adjust the receive, so you're getting the most sensitivity on 17 meter receive, is to power everything on and hook it up to an antenna. And if you have another radio, you can do this with an O-scope, but I didn't do that. I just used a second radio, transmitting into a dummy load on 18.100 megahertz. And essentially what you do is you transmit and adjust the 2 pots to get maximum sound out. You kind of adjust them by ear, and once you've set them so that you've got, again, you have to adjust one, adjust the other one, and kind of come back and play with it for a little bit, but it's fairly easy. You adjust it for maximum sound output, and then you're pretty much done. You just you put the board back in, reconnect everything here, power, make sure all your through case connectors are attached correctly, and then you just go ahead and power it on again. Make sure when you flip it on in band 2 position, you should see the 7 there, and you should be all set to go. And that's pretty much it. So fairly easy to do once you have the components, which are fairly inexpensive and easy to get a hold of, and it's a pretty easy overall easy modification to allow you to get a higher band on your older MTR3B to take advantage of the solar cycle peak here we're seeing. So hope that was a thorough enough explanation. In retrospect, I should have film this while I was doing it so you can see the other side of the board. It's just too much of a pain to take out, and I don't feel like doing that. But again, it wasn't too hard, and the only thing you do on the other side again is just replace SMD components and then do the adjustment to the receive side to maximize your sensitivity with those two little pots. So that's about it. Hope you enjoy 17 meters on your MTR3Bs.